This video is about cleaning data and manipulating data. Manipulating in the good sense of the word, just rearranging it, getting it in a form suitable for analysis. And the example I'm going to use here is survey results, which are among the messiest or dirtiest data that you can analyze, because surveys are often not very well thought out ahead of time, and the results are often really difficult to use without quite a bit of time spent rearranging the data and cleaning it up. This data, which you have available to you, is the survey results from an annual survey done by Stack Overflow. Stack Overflow is a commonly used website for software developers. So it's a very popular site for, in particular, web developers commonly use this site. So to open it, it's a text file. So first you want to change the type from JMP to a text file. And I will usually do it using a preview just to make sure. Sometimes the file is not formatted very nicely. It may have some header lines, more than one. So just to be able to see what it looks like before you try to import it, if you use the preview, you get to see, and it looks like the very top line is labels, and the first row underneath it, row 2, seems to be identifying a response from people. There's quite a bit of fields here, so we'll get to see the data as soon as we import it. You can sometimes start cleaning up the data before you import it. So like if you look at it, some data may be in numeric form or not in numeric form, and you want to change that type, you can do it. We're going to do some of those changes, but after importing it. So let's go ahead and import it. So we're at 89,000 plus responses. This was an annual survey, so this was the latest survey. I think it's 2022. And we've got 89,000 plus developers that respond to a whole bunch of things about their coding experience, their education level, platforms that they commonly use. There's some knowledge questions, asking whether they agree or strongly agree with various questions. Like I said, survey data is extremely messy, and when you start looking at some of these, you'll see how messy they get. In fact, highlight the distributions for each of these fields, and you'll see that for like tools that they have worked with, there are 33,000 unique responses. Now, when you start looking at the responses, you'll see there's a lot of common categories. So in fact, the problem is that people got to list a number of tools that they use. And so if one person listed 7 tools and the second person listed those 7 plus another one, they would have a list of 8 tools. And they would appear as if they're different values here when 7 of them may be the same from one person to the other. This is where you get into complex recoding the data in order to make it more usable. I'm going to stay away from all those complicated fields and just stick to a few. And the few that I want to focus on are ones that we would probably want to investigate as whether or not they're related to the salary. So we have a field here called compensation total. And the compensation is linked to this currency column. What is the currency that they're most commonly paid in? So there's got to be currency conversions, which fortunately they've attempted to do here. And the very last column is converted compensation, yearly compensation. So some of the compensation has been given on a weekly basis and in one currency, and another one maybe on a monthly basis in a different currency. This is an attempt that was made by the Stack Overflow people to get it on a common basis of yearly salary, and it's measured in US dollars using conversion rates. So you can look up all of the documentation about the survey to really see exactly how they did it. If currency values fluctuate enough, then you really want to pay attention to when they did the conversion, because it may be an out-of-date conversion. Most currencies don't move that rapidly in response to each other. So we'll just accept this as if it's a reasonable measure and not worry about that kind of cleaning of the data. But I want to focus on a limited number of questions here. I want to know how the compensation might compare to education, to experience, to age, things like that. So let's find those variables and see what we have to do with them. So I see two variables here about experience: years coding and years coding professionally. Are these different? Well, we'll get to investigate that, but before we do, I think we have a little bit of a problem in that if I highlight both of these, you'll notice they are both listed as nominal variables. Now, why are they nominal rather than numbers? I see a bunch of numbers in here, but you'll notice I see some letters, NA, which means they didn't answer it. It's not really a number, it really should be missing data. And then we could treat these as numbers. But I also have another problem, this less than 1 year. Less than 1 year appears in both columns and is, if I just change the data type to numbers, it will replace the NAs and the less than 1 years with missing data. That's okay for the NAs, but it's not okay for the less than 1 year. Less than 1 year is actually a number. It just means it was less than 1 year. So what I'm going to do first here is just a simple edit. I'm going to replace the less than 1 year with, I'll replace it with 0. You could replace it with 1. You could replace it with 0.5, saying it's somewhere less than a year. We'll use a half. I'm just going to decide that I'm going to make it 0, because less than a year means essentially there's almost no experience. So under edit, I'll go to search, find, and I'll restrict it to these two columns. So you restrict to selected columns, that box is checked. Oh, and I had done this previously. What you would do is you would type in here exactly what's shown, less than 1 year, and replace it with what you want to replace it with. I'm going to choose 0 here. I'm going to do replace all. It replaced 2,800 of these. And you'll notice that there are some zeros now that appear. Those are where it was less than 1 year. Now what I can do is I can go under columns to standardize attributes for these two highlighted columns. The attributes I want to standardize, I said select all, so I can change the data type to numeric and the modeling type to continuous. And what this is going to do is it's going to change all those NAs to missing data and keep the numbers and recognize them as numbers. So click OK. You now see these dots for missing data, and we see numbers for the rest. And you can see on the left, they've been changed to continuous data, so we can analyze it as continuous data. And the years coding has gone from 0 to 50. With most of the values at less experience. So is there a difference between these two columns? Do we want to treat them differently? Let's put years coding as X and years coding pro as Y, just to see if there's any difference. Here's a scatter plot of the two in relation to each other, and in fact, they do look quite different. All these points are different data points, and it would be helpful to put into this picture, close that, put into this picture, let's fit under fit special, there's an option here to constrain the intercept to 0 and the slope to 1. That means a 45-degree line that would show the two variables being equal. Let's go ahead and click OK. There is something a little puzzling here. All the points to the right of the red line, the years coding is a bigger number than the years coding professionally, because the red line would be where they're equal. These points seem a little hard to explain, so we can just highlight one of them. This person, 2 rows, 2 people in this data set shows years coding at 25, but years coding professionally at 40. It does make you wonder how you could code professionally for a longer time than you've been coding. And there's actually quite a few people like that. I mean, here you've got one row, one person that said years coding 0, which means it was one of the ones that was less than 1 year, and professionally 30 years of coding. So these would bear further investigation. One possibility would be to highlight all of these, and you could get them by lassoing them. You know, you can get most of them like this, but you can get a lot like this. You could look at them further. They've now been highlighted. If you go to tables, subset, it's pulled out what I highlighted. And you might decide further investigation that you actually want to exclude some of these or exclude the values for one variable or the other, depending on which one you view is more reliable. I'm not going to do that now, but I just want to recognize we had some issue about how people responded to these two questions, because it doesn't make sense to me that you code longer professionally than you've coded overall. The only possible explanation I can think of are people, and we might be able to tell if we went back and looked at the actual questions, but it might be that years coding was the latest job that you've had. How many years have you been coding in it? And this pertain to all different jobs you may have had. So conceivably, those were asked differently, and that might explain why we have different responses. All right, well, I'm going to leave it like it is for those two right now. Another thing you might want to look at is also how much of the data here is missing. Under tables, if we go to missing data pattern, we can just take the two columns that are highlighted. 65,000 of the 89,000 people are not missing either of those. 21,000 people have a pattern of being missing the years coding professionally, but not the years coding. And you can see 1,800 people are missing both. So in fact, most people have at least one measure of years coding. So one possibility, if we wanted to use both of the information, in other words, not lose either of these people or these people that are missing one of the two columns, is we could decide to create a new column with a formula saying the maximum of these two, or the minimum of these two, or the average of those two, as our new year's coding variable. But I'm not going to do that either, but that's something that you could do to clean that one up further. All right, here's one I want to work on. I'm interested in age, first of all, and that's here. So what are the ages? Well, these seem pretty reasonable. I mean, they're in ranges, but I would like to make sure they're in order, because if I do it like this, look at the distribution of age. Under 18, is listed first, prefer not to stay, then 65. It's a strange order. So what I think I'm going to do for this is right-click at the top and go to column properties and click value order. And you can tell JMP what order you want to keep these in. So under 18 would be the first, then 18 to 24, these all look like they're in the right order. And then there's preferred not to stay, which I might be inclined to put as missing data, but we can leave it as prefers not to stay. Click apply. Any analysis we do will now keep this order, preserve this order. There's another one I want to do this with, the value ordering, and that's organizational size. There are a limited number of organizational sizes here, but in fact, they're also not in order. If we look at the distribution of this, this is all over the map. I mean, 10 to 19, which is one of the smallest, is kind of put in the middle of it. So let's go ahead and let's do two things to this. First, let's recode this column because some of these don't make sense to keep as separate categories. I will leave the old values equal to the new values for all the ones that had numbers here. But when I get to I don't know, let's replace that with missing. Just me, we'll say, is one employee. And NA is really missing. Click recode. In the data set, we now have a new organizational size that's given the original name with a 2 after it. And let's do value ordering, column properties, value ordering on this. 1 and 2 to 9. 10 to 18 would be next. 10 to 19, 20 to 99 would be next. And you can actually take these two and move them together up. 99, 100, 500, 1,000, 5,000, 10,000, they're now in order. Okay. So you can see these are the kind of cleaning things you have to do. If you really want to use all of these columns and even the ones that we've just looked at, to do a complete cleaning job takes a lot of time, which is why they say at least 80% of the time analyzing data is spent on cleaning the data. And I think 80% is a low estimate. It actually is more than 80%. So it takes a lot of time to clean the data. And that's something that there are some tools to help automate, but they don't actually fully automate this process. There's no way to fully automate it. There's too much of it is specific to the content. You have to know something about the nature of the data and also how you want to use it. So depending on how you want to use it, you might recode it in different ways. Now let's take a look at the column that ultimately we want to tie things to, which is salary. That's our primary focus here. And we'll look at the converted yearly salary. Let's analyze that, the distribution of that. You get a fairly uninformative picture. Stacking puts it sideways so we can look at it a little more easily. That top number, that's a pretty big number. Well, in fact, one thing we might want to do here for the converted salary, just to make it easier to look at, is to recognize it. Go to column information as formatted as currency. US dollars. We don't need any decimal points here. And we'll use the 1,000 separator so that it's a little easy to see. So the maximum value is $74 million a year. Now, I suppose there's a question about whether we think that's realistic or not. Let's actually go to look at that distribution again. Well, there's a few up in that range, pretty high salaries. Let's take this lasso tool. And actually, let's go all the way down to 30-something million. Highlight those. Bottom left, that's 5 rows. So 5 people had yearly salaries converted to more than 30 million. Let's go ahead and subset those. And you don't actually have to create the subset to just look through these. We'll just take a look here. Now, these people are being paid quite a bit of money. Let's look at the ages. So I can buy that for the 55 to 64, maybe the 35 to 44. Somebody 18 to 24, that seems a little bit kind of extreme that they're making that much money. On top of it, it says they are independent. Maybe they own a unicorn. They paid themselves a lot. Some working remotely. Here's their education level. This one seems very suspect. That's the young person. Oh, no, it's not the young person. This person only has a bachelor's degree, 55 to 64. No, they're probably, president of their company, something like that. Well, it says they are a developer. They learned to code in school, 45 years of coding. Let's just look at what their original salary was. So they were in Australian dollars. That I can believe. This top one from Mali, I don't know that currency, but maybe that one is kind of suspect the way it's been converted. The one from Thailand, also the Thai currency, maybe something went wrong when they tried to convert that. These are Canadian dollars, 2 of them. The third one looks particularly suspect to me. That's the young person, 18 to 24 years old. It says they have no years coding as a pro, but 3 years of coding experience overall. They're in Canada. They work in a small company, 2 to 9 people, making $74 million a year. So we could go through these individually. You might decide to exclude some and not others. I would caution you not to exclude data very quickly. I mean, if you find that it's in error or it's simply not believable, then excluding it probably is the best thing to do. But if it just seems unusual, that's part of the data. I mean, data can be unusual. It's part of what you want to analyze. So generally, I do not exclude data unless I have a really convincing reason. Convincing reason is not that it looks funny. That's what I would say a poor reason to exclude data would be. In this case, because I want to analyze how salary is related to these things, and these salary levels are so far out of whack with everything else, if we view this as a survey of developers, these people are not getting paid this money for their role as a developer. If they are in fact getting these salaries, it's because they founded the company and they're no longer, they may say they're still developing, but they essentially sold off their company to somebody for a large sum of money. So these are not developer salaries. So I'm pretty comfortable for my purposes of analyzing the salary in relation to things like experience to say that these 5 data points are actually not useful for that kind of analysis. So under edit, under rows, I'm going to do hide and exclude. They will be excluded. You notice bottom left, it says I've selected 5, I've excluded 5, I've hidden 5. They won't show up in any analysis I do. They won't be used. It's like they're not there. That is better than deleting them, because at some point you may want to go back to them and actually see something about them. So once you delete them, they're gone. Hiding and excluding does the same thing as far as any analysis you're going to do. So now if we look at the distribution of the converted salary, it still is a very skewed distribution. We've still got some people with 10, close to $20 million. Is that what that is? 17, almost $18 million of compensation, which is a lot. On top of it, the histogram doesn't really tell you much, except that there's a whole lot of outliers here. Almost any monetary distribution is going to have a very skewed shape, where most of the data is at fairly low values with a few very high values. And it can't go below 0, so that would be the lowest you would get. Somebody reported $1 here. Might be able to get the histogram to look a little better. You click on this hand tool, and if you go inside this bar and shift up, it introduces additional bars, but you still can't see them very well. We have a very small number of people earning these high salaries, the vast majority only in these first couple of bars. One common thing to do when analyzing data like this that's very skewed is to actually, instead of excluding the very high values, use a transformation of it, a nonlinear transformation. The most common one, if you right-click here, you can go to a new formula column, and if you take the logarithm of this data, take a look at what that distribution looks like. You can see the picture up here. It's a much more symmetric distribution, because with the logarithmic transformation, it collapses the scale, so the numbers that are really much higher they're much more in the same vicinity. This maximum of $17+ million is, in logarithmic terms, only 16.7. And if you look at the distribution of the logarithm, the picture seems a lot more revealing to look at. You can actually see the bars. It has a somewhat slight negative skew instead of a positive skew, where we have more values on the left side than on the right, and they extend down quite a bit. That's because we have some very low salaries, but it's a much better behaved distribution. Visually, you can see what the distribution looks like. And it would even probably look a little better if we added a few more bars into it. Okay, so let's just start doing a little bit of analysis here. I'll do this using Graph Builder. There are several other platforms for analyzing, but for visually inspecting data, Graph Builder is your go-to platform, because it contains a lot of different options about how to visualize this data. So let's take the converted compensation and make that a Y variable. And then let's look at something like years coding. Well, this line looks pretty small, but again, that's because the compensation levels go up to 17 million. And so in relation to years coding, what's being shown here is actually, it's called a spline. It's kind of a smooth line through the data points. If I put in the data points, now you can see that for each number of years coding, there's a variety of data points, including a few that are sitting up here at the really high levels. Can't really see those points, so let's see if we can make them a little bit larger. It's under graph marker size. Now they're a little easier to see. So that person with the highest salary actually had a modest number of years coding. I'm not seeing a clear relationship here, but there's really too many points to look at the individual points. So if I switch to the box and whisker plot, it's a little bit better. You can start seeing the box part, which is 50% of the data, seems to be sort of going up a little. I almost start seeing it going up a little and then starting to go down. That if you've been a lot of years, maybe salary starts getting lower. If instead of looking at the distributions, we just want to summarize it by looking at the average. Well, now we can sort of see the average salary seems to be going up with years coding and then kind of levels off. So once you get 40 years coding experience, salaries on average are not getting much higher. Let's go back to start over. Instead of years coding, let's look at the organizational size. This is the missing data, and the rest are in the order that I asked for, that I put in that column as the value ordering. And let's drop the salary as Y. Let's just look at the averages. Now, there are two ways to look at this. This is not bad because we put them in order of size. So as you go to bigger organizations, you can see the salary, average salary is getting higher, with the exception of the single one person. They actually are reporting average salaries over 100,000. So in relation to size, I would say generally working for bigger companies is a higher average salary, with the exception of the ones that are missing. We don't know what size organization they work in, and the sole people working alone. Another possibility here would be if you go in the x-axis and right click, you can order it by, let's say, converted compensation descending. And now the bars are easier to look at, although it now makes it harder to think about this sort of how the sizes vary. So you can see which one has the highest average salary, the biggest organizations, and then the next biggest, and then the next biggest, and then we go down to the single people working alone. So in this case, I don't think I would order them that way, but you'll see in many cases, the bar charts are vastly improved if you do put it in ascending or descending order. The difference would be when you have something that has a natural value ordering, like the size of the organization. Well, we'll see an example of that right now. Let's go back to here and let's look at the location. We have a country variable. Now, if you look at country, there are 186 countries represented here. That's too many to look at, although you'll notice that the top ones, United States has the most, Germany next, India next, the UK next. So only a few of these have a large number. So what I'm going to do is I'm going to recode this column, but I'm going to do it a little differently than just a recode. If you go into columns and you went to recode, the problem is you have 181 here, and most of them you'd want to change. The ones that only have a small number, 57 people in Iceland, I don't know that we want to keep Iceland as a separate country, whereas India has 5,625. So there's only a few that you'd want to leave alone, and the rest you'd want to change to, let's say, other or small countries. I don't want to go through 180 plus values and change each of them to small countries. So I'm going to do this a different way. It's kind of a nice tool to use. If we look at the distribution of country, let's just look at the ones that are kind of large. Click the bar for US. It has now highlighted those rows in the data set. That's 18,000 of the 89,000 people. So they have been selected because I selected that bar. Once they're selected, you can go into rows to row selection, name selection in column, and we'll call it, I'll call it country with a small c. And the selected ones I'll put as US. Don't put anything as the unselected, just click OK. Now go back here, highlight a different bar. This is the UK. Go into rows, row selection, name selection in column. It pulls up the column I just created called country. And the selected ones now I'm going to do as UK, leaving unselected blank. Let's see what other countries are pretty common here. So there's the India bar. Row selection, name selection in column. We'll call it, oh, excuse me, still country. Just gonna call this one India, leaving unselected blank. This is Germany. See, there's Canada, there's quite a few in Canada. And there's a few here in Australia. We certainly could put in more. But just for my purposes, that's really enough. Well, let me do one more, see if this works. So click on Australia. Yeah, I actually don't know, but we're going to find out here in a second. Trial and error is something wonderful to do in JMP because usually you don't lose much work and you can just redo it. I want to make all the others just other. So I'm tempted to put other in here. The only question is whether it's going to overwrite everything other than Australia as other, including US, UK, and the others. We'll give this a try. Yep, it overrode all the others, which is not what we wanted. Can we undo that? No, we can't. Oh, I know what I should have done. So I'll show you what I should have done here just by putting back those as US and back to UK ones. And I guess there's two others. I should do India and Germany. Oh, and actually, since I had other created, yeah, I guess I should have put other in the very first time I did this, and then it would overwrite the others with the other countries that I put in. So I just did the order wrong. But now you can see what I'm left with here is only 6 values: other, US, Germany, India, UK, and Australia. And now let's say we want to see how salaries vary. So I'll put country down here and the converted salary up here. Let's make this bigger. The option right now that's showing is box plots. A little hard, too many data points to actually see and compare that way. Although that's a lot more information than if we simply went to a bar chart and look at the average. Or since it's a skewed distribution, we might change to the median. That only changed it a little. This is an example, though, where this has been put in alphabetical order because that's the default that JMP uses. So that's why Australia is on the left. This picture is not nearly as easy to look at as if you right-click here and went order by either ascending or descending, converted compensation descending. So the US had the highest average salary, followed by Australia, UK, Germany, other, and India was lower. So not surprising given the sort of relative incomes in these countries, but much more appealing picture once you've got them in descending order. If you were writing up a report and this is the picture you wanted to use, you could copy this graph, but a couple of options of things you want to change here. First of all, having the median out here does not help. So I would say click on the red arrow and do not show the legend. You usually want to change the titles and actually say median annual compensation by country. And this one is measured in yearly compensation. The titles that computers use are almost never what you want. So it always pays to go in, and this is just country. In fact, I don't even think you need that. Probably you just leave that out. And the next thing is when you want to copy and paste this, if you copy and paste, like if you go under edit to copy, it will copy all of this irrelevant sort of material, which is just sort of the placeholder for where you want to drop things. So if you get rid of this, you click on the red arrow and don't show the control panel, now you have a much cleaner picture, and copying and pasting this will be a lot better than having those borders that were just sort of drop zones. Let me put back the control panel and let's actually redo this a little bit differently. Let's go ahead and put country down here. And then let's take converted compensation here, like we did before, change it to bars. Now let's go to work experience, which I think was years of work experience. And if you drag it on the y-axis below the other, then that is a separate graph. So you get the work experience in one color, the compensation in the other. Let's order this by compensation descending. You know, there's a slight difference here between the US and Australia in that Australia had considerably lower salary, but actually a little bit higher average experience than the coding experience for the US programmers. But by and large, these two really suggest that there is sort of a positive relationship between years of experience and compensation. And so we've got them shown by country. Another way we could have shown this is we could take the work experience and put that as X, take the compensation and put that as Y, and instead of a linear scale here, let's make it a logarithmic scale. I could have used a logarithmic column, but this actually at least puts the data points sort of back in the picture. This is just the sort of smooth relationship. These splines actually give you a control over this value lambda. If you move it to the left, it starts smoothing. It makes it more jagged. As you move to the right, it makes it smoother and smoother. So you can say approximately it looks like more work experience relates to higher salaries, but again, it levels off after about 25 years. What might be interesting is to add another variable, and so we might take country and add that to the overlay. And now actually let's take away the points. Seems to be a little bit different here in that in India, it's a pretty steep curve. The more years of experience, the higher the salary, and it's continuing even after 50 years. So the more experience you have, the higher salary is in India, whereas all the other countries seem to reach a point and level off. And in fact, if you look at the other, it not just levels off, it actually seems to kind of decline after a certain point. So experience counts for more in some places than others. So lots more discoveries you can start making now. And it's not unusual when you start exploring it that you say, well, I really want to code this a little bit differently. Maybe I want to have other countries, or maybe I want the organizational sizes to be different. So now I've got this. We could actually take organizational size and add another variable in. Let's drop this in the wrap box. And now you get a different, take rid of the control panel, a different picture for each of the organizational sizes. And it looks like the India line, the green line, has a similar shape for all of these. So it seems like regardless of the size of the organization, more experience you have in India, the higher your average salary is. And all the other countries seem to level off at a different, all the organizational sizes seem to level off. So this would tell me organizational size is not an important variable, doesn't give me a very important, any important difference in the relationship between work experience and salary. So maybe that's a less important variable to worry about when I'm just looking at the focus between those two variables. So Graph Builder allows you to get a fair number of dimensions into the picture at the same time. If I undo that last step, another option for this would be to take a local data filter, and we'll take our recoded our organizational size, is our local data filter, get rid of the control panel. And now you can go through these. So we don't have that many single people working in this data set, so you get these kind of some funny shapes here. But if you go to 2 to 9 employees, that's what it looks like. Here's for 10 to 19 employees. Here's for the largest companies. And so data filters sometimes is an easy way to, rather than putting in the wrap box and having all of these small pictures where they all look very similar, this would allow you to focus on how they may change. And another thing you might want to do here is to, I think it's here, lock the scales. So as you switch between these, if they're going up or down, the scale will stay the same. I don't see a lot of movement in terms of the average this is the converted compensation in logarithmic terms. So remember, the logarithm makes makes big differences, collapses them to much smaller. So if we look at the overall salary itself, we would probably see that there's some difference. A change on a logarithmic scale that's small actually is a lot of dollar change. We might be able to see what that looks like. I pull this out and put in the original converted salary. Not lock the scales for a minute. And there's bars for the work experience. I guess I'll go back to lines. Okay. So with straight lines fitted through the data points, this is showing the line is showing the relationship between work experience and converted compensation for each of these countries. The US being the highest here. For the other countries, it is the steepest rise. So with work experience, salary itself increases more rapidly in those other countries than anywhere else. The slope seems very similar for Australia and the US and the UK, and not that different for Germany either. So, and India has a somewhat steeper slope than those. But here's where the filter actually can help. Let me lock the scales. Get rid of the control panel. And now as you move through to bigger and bigger organizations, you can see how those relationships may change. Notice when you got the biggest organizations, they sort of went up. So higher salaries across the board in terms of the relationship between these two. So certainly a lot more you can do with this. I give you the data, you can play with it as you want, but basically, these are a number of the kinds of manipulations of data and preparation you want to do for analysis, some of the beginning analysis you would do, and a little sense of how the sort of, this is an iterative cycle. When you start looking at these visualizations, you start discovering things that you might want to go back and change in the data before you get the right visualization. So you often have to look at the data in order to know how you want to recode it, or if you want to recode it, or if you have values that look suspicious and should be excluded. Those are almost always involve visualizing the data, then going back and changing the data, and then revisualizing it. And I will stop there.